So I wanted to give some information for teachers for this experiment, specifically the 3 little experiments that we did with the same 16 samples. So first, looking at solubility, there's definitely some substances that I would call slightly soluble. So for example, cornstarch, you can see, and this has been sitting overnight, you can see that it's still cloudy. So there is quite a bit of undissolved material in there. But then you'll see it does register a conductivity, a small one, under 200. It does register a conductivity. So we know that some of it has dissolved. So I would just counsel students that if they see that it's cloudy, and even letting it sit for a while and none of it settles, you don't see a clear distinction of settling out at the bottom and then clear liquid above it, I would say slightly soluble. Okay, so I would call that one slightly soluble. If it's very clearly not soluble, like this one, there really is no reason to do a conductivity test, because the conductivity test is meant to be only for the substances that did dissolve. We just went ahead and did all 16 substances anyway. That could be a conversation that you have with your students. When we were doing conductivity for the paperclip and the galvanized nail and the brass, you would see a slight number show up on the meter. And that's potentially because we're not using distilled water in the cup, we're using tap water. And also any residual matter that's on the probe is also contributing to the meter reading. So even though I did kind of a cursory rinse of it in between each time, unless you do a really, really thorough rinse, you potentially are taking some of the previous material into your new sample. So all of those readings were under 200, so students should still be indicating no on their data table, but I just wanted to give some information about why we may be seeing a number at all. So looking for values that are greater than 200 indicates a positive conductivity. Citric acid is a little bit tricky here. So we're seeing it totally dissolve. There are no particulates left over, but then we're seeing a value that's under 200. And so citric acid is tricky because it is quite soluble, but it's also a weak acid. So because it's a weak acid, we're seeing that it dissolves, but then we're not seeing the conductive nature of it because there's not enough ions really to so that it can be conductive. So citric acid is one that you may or may not want to leave out of your item set, depending on how deeply into the conversation you want to go with your students. Because as you start organizing your results and grouping them, this one's going to kind of stand out to the side. It dissolves, so we're expecting it to have some kind of an outcome, but then it doesn't have that outcome, and then it's a little bit confusing for students. So depending on how much you want to talk about that with your students, citric acid is one you may want to leave out. Let's see. Then I would say another for solubility, a little bit tricky. We used about 40 mils of water in our beakers, and so you just want to be cautious about the size of the scoop of the material that you're trying to dissolve in the water. If you're adding too large of a scoop, you may not get it all to dissolve, even though it's completely soluble substance. So you want to be careful about your substance to water ratio. So just the tip end of a spatula potentially is enough, right? You're going to get enough ions in there to conduct if it is conductive. So just being careful of that ratio. And then finally, for the melting, remember it's a yes or a no. So we're not really looking at the temperature. Although if you look at the key in the restricted folder, you can see that some temperatures are recorded. And so we did look up the values so that we know what they should be, so that we can kind of check the yes or no answers for students. But students themselves are not trying to determine what the melting point is. It is tricky using a Bunsen burner to try not to ignite the material itself. So counseling students to look carefully for bubbling as a sign of melting versus smoking or turning black, which is a sign of burning the substance. So maybe modeling that for students to show them the difference between those two. We had a couple of examples in our video where we did see bubbling, and then we did see a different sample turning kind of black and crispy around the edges. Sugar was a little bit tricky because when you melt sugar, it does turn slightly brown as it caramelizes, but then there was also bubbling. So you had to look kind of carefully at that one. But otherwise, that's kind of the feedback that I would want you to know going into the experiment. And good luck.